Okay, so I want to take a moment to go over ionic bonds. We already have covered covalent bonds and we've talked about ionic bonds also, but this is more of a review. First of all, bear in mind that ionic bonds occur between a metal and a non-metal. Most of the time, atoms are neutral, meaning they have the same number of protons and electrons. But atoms can gain or lose electrons, and when they do, they can become ionized. So what happens to metals is that they will give away all of their valence electrons and they will become what are known as cations, which are ions that have a positive charge. Now they're losing electrons, and the reason they have a positive charge is because electrons are negative. So if an atom has more protons than electrons, it's positive. If an atom has more electrons than protons, it's negative. Nonmetals will form anions, which will become a negatively charged particle. To do this, we need to make sure we're using the oxidation numbers. We get those from the periodic table. So looking at the periodic table, remember that we need to show what the oxidation numbers are of all the elements. Okay? So I'm going to go ahead and I'm going to separate the metals from the nonmetals with our line. Okay? So everything on this side of the line, the left side of the line, these are all metals. On the right side of the line, those are nonmetals. Our oxidation numbers are positive 1, positive 2, positive 1 or 2 for all the transition metals. Over here, positive 3, positive 4, or negative 4. And then from 15 to 17, those are negative. So we're going to have negative 3, negative 2, negative 1. And again, group 18 does not form an ion. So if we want to look at what kind of bonds will take place between these ions, we're going to look at the oxidation numbers for different elements. So here I have magnesium and oxygen. When they come together, remember magnesium's in group 2, it's going to have a positive 2 ion. Oxygen's in group 16, it has a negative 2. Remember, metals give away all their valence electrons, so the number of valence electrons they have, that's going to be the same as their oxidation number. For the nonmetals, their oxidation number will be the same as how many more electrons they need to have a valence level of 8. We crisscross the numbers to get the chemical formula. And that becomes Mg2O2, known as magnesium oxide. Bear in mind, we do not use prefixes when naming these compounds. Sodium has a positive 1 charge, bromine has a negative 1 charge. So when they come together, we crisscross the numbers, and we get sodium and bromine. We're not going to write down the 1.